Swayam Prabha. Digital India. Educated India.
Welcome back to the Bioenergy course. So, we are following the gasification. Okay. In the gasification, we have covered the introduction of gasification, and in the previous class I requested you to give maximum thrust on the chemistry, because that is most important, the chemistry of gasification, where we have formation of carbon dioxide or formation of CO depending on what is the level of partial oxidation taking place, and then the hydrogenation reaction where CO plus hydrogen making CH4 in the presence of water, and how the efficiency shifts and how the efficiency goes down in the presence of nitrogen. So, now today what we will do, and after that we talked about in the section 3, we talked about the pre-treatment of the feedstocks followed by the properties of the feedstock. So, today what we will do, we will come to the 5th section of it, which is our gasification types. So, this is E or 5th section, gasification types. So, in terms of the different types of gasifiers which have evolved through the years and through decades, we have 3 different kind of gasifiers which are available. One is called the fixed bed gasifier, the other one is called the fluidized bed gasifier, and there is a third one which is entrained suspension gasifiers. So, let's put them together under one schematic. So, the most commonly used is fixed bed gasifiers. Second one is fluidized bed. The third one is entrained suspension gasifier. Entrained suspension gasifier. So, in this course we will not really talk much about this entrained suspension gasifier, but just for your general knowledge, these kind of gasifier are very suitable. So, if you are in industry and you needed a situation where this is very suitable for very fine particle, okay, suitable for finely divided particles or feed material particles or slash feed materials, okay. And the size in which it works is less than 0.1 to 0.4 millimeter. And these kind of particle size is very tough to achieve in when we are talking about fibrous materials. Fibrous materials are typically between 20 to 80 millimeter, and here if you see the number, it is around 0.1 to 0.4 millimeter. So, that is why, so this is not really not a choice for fibrous material, okay. Fibrous materials. So, but this is just for your general knowledge. If you have a situation of very fine particles to be processed, to be gasified, and you should go for entrained suspension gasifier. Now, what we will be dealing in depth are these two, fixed bed and fluidized bed. So, we will start off with the fixed bed. Okay. In terms of the fixed bed gasifier, these are the very old traditional gasifier. So, it is a traditional process, and the temperature at which it works it around 1000 degrees centigrade. This is very, and further fixed bed classifier could be classified into 3 different categories depending on how the airflow is happening into the system. So, it is a function of the direction of airflow, okay? Direction of airflow. It is considered as updrift, fixed bed gasifier, downdrift, updrift, downdrift, second one, and the third one is the cross flow. Okay, cross flow. Okay, so here it will go updrift, downdrift, possibly there is a cross flow like this. Okay. So, what we will be doing first is we will talk about in depth about the updrift gasifier system. So, before we put down the notes, let us draw the schematic of how the gasifier, updrift gasifier looks like. So, this is how it more or less looks like. Okay. Okay, so this is the kind of okay. Now, okay. So, you have one port coming out like this, another port coming out like this, and okay. The other side you have, okay. Now, one second, okay. So, there is a port out here, and there is another port out here, and I will label all the ports. It will be very clear to you people. Okay. Okay. And you have 3 different zones. I am changing the color for your understanding. Okay, I am shading the region. Okay. This is the green, this is from where you are putting the biomass into the system. Okay. Now, followed by underneath it you have just bear with me a little bit. Okay. And okay. So, now this is the top, what you see, that this is where you feed the biomass. This is the biomass feeder. Okay. So, now this orifice what you see out here, through this is from where the tar which comes out, oil and gas. This is kind of through which outlet. Okay. This is the drying zone, and out here what you see, there will be lot of filters which are here, you can put a lot of filters, or you can put them externally once you are there coming out, where you have to trap the tar and all other stuff. Okay. This is the drying zone. This particular location is called the devolatilization zone. Volatilization volatilization zone. This zone is the reduction zone, and underneath you have okay, and this is the combustion zone, and this is where you are having the air coming in. This is the air orifice, and the air is moving like this, okay, and this is where you have the ash. So, the air movement. So, I told you this is what we termed this as updrift. Okay. This is the updrift gasifier. Now, you see how the air is moving. So, you have a structure like this, right, and you are supplying air from the bottom and you are supplying the feedstock like this. So, air drift is like this, okay. From bottom it is going up. So, that means you are pushing the air to move upward. That is why it is called a updrift gasifier, and these are the different sections of it. If you see the cross section, so let us go through it. So, here you have the biomass feeder present here, okay. So, which is essentially this zone where you are feeding the biomass, which I am now highlighting in green, okay. Biomass feeding zone side, okay. Okay, and then you have the drying zone, which is present here. Okay, so this is where you are drying the stuff, and while drying, several things goes exhausted out through this port. This is the port through which is going out. Then you have the reduction and the combustion zone. So, here you have the reduction and the combustion zone. So, this is the drying zone, okay. And this is where the devolatilization taking place. If you remember, while we talk about the volatiles, I told you that if the material has most of these have lot of terpenoids and other compounds which are volatile matters, and they have to be, it has to be ensured that they do not unnecessarily escape out into the environment. They have to be trapped and converted to some value added product, or at least should be a way to dispose them of. So, this is where, so you are having the sample, you are drying the sample, that brings you to the basic concept of removal of water. Next, you remove the volatile matter trapped in these molecules, or because of the hydrocarbon breakage and everything, there are a lot of volatiles which are produced there. So, this is the devolatilization zone, and your air supply is coming all the way from the bottom like this, okay. And this is why it is called an updrift system. And here is your combustion zone, here where you are doing the combustion process, all the reduction and everything which is happening here. So, since your movement of air is like this from bottom to up, we call it a updrift system. Now, if you look at this system, there is a very interesting variation in the temperature across the system, and that is what I am going to highlight now. I will draw this by the side of it, and that will give you an idea what I am trying to tell you. Okay. So, say for example, so let me divide it into the x axis in terms of the temperature. You are starting the axis at 1400 degree centigrade, 1000, 600 or 200. And if you follow exactly what is the temperature here, what is the temperature here, what is the temperature in this combustion zone, you will see a very typical pattern of something like this. At this zone, and this will come very handy for your understanding, the temperature started increasing and then it attains the maximum in the combustible zone, and then again it stops. So, what does this picture tells you? What just now I draw, like this, falling and then moving and then. So, it means that inside this gasifier the temperature is not uniform. So, the temperature varies at different part of it. So, at the drying we are talking about, if you look at this, okay, so at the drying level we are talking about a temperature around. So, if you follow it up to this, temperature varies from around here, where is the drying zone taking place, in and around 200 or something, okay, little more than 200. Okay. Now, if you go down in the devolatilization zone, which is out here, the temperature is hovering somewhere here, which is out here. And if you go further, where is the combustion zone, we are talking about this temperature. So, you see, you can classify the zones where the temperature is higher, zone which is lower. So, it means the biomass is going through a time, of course, it is taking time to move through, and in terms of varying temperature. Okay. And your air supply is coming from the bottom, okay, like this. And whatever combustion is taking place, the ash is getting collected out here. You see the ash is getting collected here. Now, let us pull our attention to some of the salient feature of it. Okay. In the drip gasifier, updrip gasifier, some salient point what you people needed to remember. Salient points regarding updrift gasifiers. Okay. The salient point, the first important point is that immediately above the grate, immediately above the grate. So, the grate is sitting out here, if you look at it, out here immediately, okay. Immediately above the grate, the solid char, or the, which is basically the residual solid remaining after release of volatiles, okay. Residual solid left after minus removal of volatiles, okay, formed higher up, solid char formed higher up the gasifier, okay, is combusted and the temperature reaches about 1000 degrees centigrade, okay, reaches about 1000 degrees centigrade. And I showed you in the, if you follow the picture right, I would see the ash, this is where the ash is falling down. So, all the important things are all happening here, okay. All the major critical aspects are happening here, and the ash is basically falls through the grate at the bottom, falls through the grate at the bottom, okay, and the hot gas pass upward and are reduced, pass upward and got reduced. This is what you have just now observed. Ash falls through the grate at the bottom and the hot gas pass upward and got reduced. So, look at it. So, here the ash is getting collected as the air is moving, it is getting, so here all the combustion and all the chemistry is happening, and the ash which is coming out is now falling down like this through the grate and it is getting accumulated out here, whereas most of the gas or products which you needed, product gas, is all forming out here in this location. Okay. So, the next important point for you people to remember is higher up the gasifier again, okay, higher up the gasifier, again the biomass is spiralized in the top zone, higher up the gasifier, biomass is spiralized and in the top zone, okay, the feed is dried. That is what you have seen, the drying zone. If you follow the picture, so this is the drying zone where the feed is getting dried. Okay, feed is getting dried, top zone, and the feed is getting dried and cooling the gas at around 200 to 300 degrees centigrade, which you can follow. If you follow this stuff, this plot, you will see around 200 to 300 degrees centigrade, where in this zone the gas is kind of getting cooling down. So, what the gas you are obtaining is around 200 to 300 degrees centigrade, and which is easy to handle at a lower temperature, and the efficiency of the system is much higher at such temperature. Okay. So, coming back, the third important point what you will have to remember is in the pyrolysis zone, where the volatile compounds are released, considerable quantities of tar is formed, which condenses partly leaves the gasifier to the product gas. So, that means basically in the pyrolysis zone, where the volatile compounds are released, considerable quantity of tar is formed, considerable quantity of tar is formed, okay, which condenses partly on the biomass higher up, which partly, and this is a very interesting aspect, partly condenses on the biomass higher up, biomass higher up. What does that mean? Okay. And partly leaves the gasifier and partly leaves the gasifier with the product gas. So, this is very simple. Now, refer to the diagram, you will see what is happening. So, the gas is moving up. Okay. So, this gas is out here, the air is blown and the gas is formed, it is moving up. So, now this gas, it is in the pyrolyzing zone. Okay. Part of it escapes out, as I just noted, and part of it kind of is absorbed along with the tar on the biomass which is getting fed. So, okay. So, this is a zone where you are losing some of the efficiency of the system, the overall efficiency, because some of it again got absorbed into the biomass itself. So, it is not that whatever is forming is coming out. So, there is a kind of mixing, partial mixing which is happening, which was basically to highlight the fact that in the pyrolysis zone, where the volatile compounds are released, considerable, so this is important, considerable quantity of tar is formed, which partly condenses on the biomass. So, you have this tar coming, okay. If this is the tar material, So, and here you have the biomass material. So, it is condenses on top of it like this, okay, and part of it of course leaves it as along with the product gas. This is another important aspect about it. Now, there is a fourth point about this updrift gasifier we needed to highlight, that is temperature in the gasification zone is controlled by adding steam. Okay. So, temperature in the gasification zone is controlled by steam, okay, and adding steam along with the air which you are blowing from the lower side updrift, okay, which further basically leads to, if you are humidifying the situation. So, while I am writing this, I wanted to show you those 4 reactions what I am highlighting. If you look at them again carefully, you really do not need to remember things, by logics you can put it in place. So, think of this situation here. See here. So, this is, say for example, is coming as a steam. Okay. What will happen? So, this will lead to the methane production, CO, H2O. This is not, you can really put the steam in order to control the temperature, because the steam has a much more higher temperature. Okay. So, coming back to the points, what I was trying to highlight is that temperature in the gasification zone is controlled by steam plus air, thus humidifying the system, okay, humidifying the air. This is how you are controlling the temperature. So, there is a fourth point, due to low temperature of the gas. This is why I mentioned that the temperature which is by which at the gas is coming out is around 200 to 300 degrees centigrade. If the gas is leaving at that temperature of 200 to 300 degrees centigrade, the efficiency of the process is high, as well as, so this leads to 2 advantages. So, this leads to higher efficiency, process efficiency is higher, plus the recovery, gas recovery is also higher. And the last important point is the filtering effect on the feed helps to produce gas with low particulate content. So, filtration to reduce particulate content in the gas. So, again let us refer to the picture. This is what I am trying to tell you. So, here if you put lot of filters out here, you can trap the tar, you can, of course, this is a caustic proposition, you can trap the different particles. So, this is where you have all the different kind of particle / tar trapping filters. Okay. So, these are the points which is salient point of the gasifier. First of all, immediately above the grate, so that is where the solid char residues left after the volatile is being removed form higher up in the gasifier combusted, and the temperature reaches about 1000 degrees centigrade. This is critical, this is what temperature, and the ash falls through, as we have already seen in the picture, ash is falling through that stuff which is present there, which is basically from where you are allowing the air to flow. So, you have to ensure when the ash is falling out, it is not blocking those ports through which the air is going to go up in the stream. Second, what we talked about, higher up the gasifier, biomass is pyrolyzed in the top zone and the feed is dried, and the cooling the gas to around 200 to 300 degrees centigrade. And in the last part we mentioned that 200 to 300 degrees centigrade increase the process efficiency as well as the gas recovery. Okay. And another aspect the temperature out here is controlled by the steam. So, the take home message for most of it is lying in your chemistry, those 4 reactions. If you understand those reactions, then what is happening inside the gasifier, you can pretty much imagine even without seeing a gasifying system. Okay? So, remember those 4 reactions, and this is the first gasifier we have talked about today, which is the updrift gasifier. Next we will talk about the downdrift gasifier, and then the crisscross flow gasifier, what we will be talking about, and then we will go to the fluidized bed gasifier. So, once again my take home message will be, please be very careful with the chemistry and try to put your imagination in place. Based on that, you can even design a much more highly efficient gasifiers. Okay? Thank you.